a very low price point. So they've got a couple of models out, but the cheapest one I think is about $60 US. So, compared to, I don't know what you pay for a desktop GPU, orders of magnitude cheaper. And this has really allowed a lot of people to experiment with these things in places they probably wouldn't have done otherwise. So let's get straight to where am I using it. So I'm running Home Assistant in my home. I'm not going to assume you're too familiar with this, but it's a home automation platform written in Python, and it's all open source. And so I've got a couple of camera feeds in my Home Assistant, and this actually here is a screenshot of what my object detection has seen outside the street of my house. So, okay, so let me show you a bit more information there. So basically, I wrote sort of a plugin for Home Assistant that connects to another project which I've been working on called Deepstack, and that allows Home Assistant to use Deepstack as the engine for doing object detection. So basically, yeah, you create an integration Home Assistant so that it's capturing frames from video cameras around the home, processing those with Deepstack, and presenting the results in Home Assistant. So this is just a sort of screenshot of the information that Deepstack has found in that particular image. Basically, you give it a list of things you care about, a list of objects, confidence thresholds, and it processes the frames coming off the camera. And when it detects targets that meet the criteria that you set, it will then give a running tally of the number of targets that is found. And what I originally used this one for is to find out when there was a parking spot free outside my house, because we've got quite a busy street, and if you weren't able to park outside your house, you might have to walk for a long time to find the spot. And so I set up Deepstack to look at the spot outside my house and tell me if it was free. So if my car was down the road, I could bring it and put it outside the house. So that's one of the things I was doing with it originally. The other thing I've been doing with it, and you can't see anybody there now, but I can show you some shots of what it does. But basically, I've got a motion activated camera at my front door. And you know how you have those Ring doorbells, which basically, somebody pushes a button and it takes a photo and it sends that to the owner of the home. I thought, well, it'd be much more fun to create one that you don't even have to push the button and it does it automatically. So the first iteration of that was basically a motion triggered camera. But the thing about that is you get lots of false positives. Somebody walking by in the street would set it off. So that's really what started me down the journey of trying to get object detection running in a home. And now the way it works is it's still a motion triggered camera at the door. But now, actually, each frame that it's captured is sent to the Deepstack engine. And then if it finds a person in the frame, then it will send me a notification. So it's kind of like a Ring, but with added AI brains and without all the fees, etc., that go with that. So those are the two things I've been using it for. So out of curiosity, have we got any other Home Assistant users here or anybody else familiar with Deepstack?
Unfortunately, not yet.
Not yet. I know it's just a matter of time, Francesco.
It is.
It is fantastic. So yeah, that's how I'm using it in my home. This is running on a Jetson Nano that's sitting in my living room and connected to the router. We can go a bit more technical on that. Or the other option is to cover one of the other projects I've been working on, which is using a Raspberry Pi. That I'm assuming maybe a few more people own a Raspberry Pi than they do a Jetson Nano, but it might create quite a good sort of talking point about sort of practicalities of deploying object detection, in the home or at the edge. So, have we got any Raspberry Pi users around?
I am one of them.
Okay, fantastic. We've got one. It's so quiet when you're talking to yourself. It's a little bit weird. But I see you're still there and you're still listening.
We are here.
Yeah.
Okay.
I also want to start experiment with Raspberry Pi and Jetson Nano, but not there yet. But I do want to get there.
Cool.
I have a bunch of Raspberry Pis, but yeah, so that'd be interesting.
Okay, fantastic. Yeah, Raspberry Pi is one of those computers that, everyone's got like a couple sitting in a drawer and they're like, what on earth can I do with that? Two suggestions: you can put Home Assistant on one of them, and the other thing you can do is do object detection or face detection in the home with Raspberry Pi. It actually works reasonably well. You're kind of limited by the memory on a Raspberry Pi. I think that when I was doing this before, there was like 1 GB, and you'd have this situation where if you loaded up a model, a face detection model or something, you might get like one inference off it before it would then crash, saying I haven't got enough RAM. So this was always a bit of a pain point with the Raspberry Pis until quite recently. Two things happened more recently. So they released a newer version of the Raspberry Pi, which is the Raspberry Pi 4, which really bumped the memory available on the Raspberry Pi. So now I think you can get up to 8 GB RAM on a Raspberry Pi. So the model loading wouldn't be an issue now. The other thing that happened is Google got into the Edge AI game, and they released a range of products under this Coral brand. Let me just show you that because it's pretty cool, actually. Google Coral, here we go. And I guess this is Google's platform to put Edge AI at the edge. And so what they've done is they've released TPUs that are low cost and can be integrated into products or can be run standalone on a sort of either USB stick kind of device, which is the one that I own, or they have their own single board computers that have this TPU on there as well. And this is actually a really interesting site to have a look at because they have a few companies that are using this TPU Coral product in sort of some really interesting applications around like detecting. I think there's some around like detecting if people are wearing PPE, protective equipment in the COVID situation, or looking at safety stuff. And along with the hardware, they've got this. Sorry,
Rob, just a quick question, please. Like, do they have also GPUs or only TPUs?
So TPU is their take on the GPU. So
okay.
I mean,
right.
I think it's like highly optimized to run TensorFlow, basically.
Got it.
Hence the name. So we can get into the whole Google versus others conversation at the end, but it does. If you're thinking about getting into Edge AI and practical deployment, that might be something you need to consider up front. Do you want to be in the Google universe or in the PyTorch Facebook universe, or is there some path you can go in the middle?
Right.
So yeah, just to recap, my first project was with the Raspberry Pi because I had a few lying around, and I was like, okay, let's see what kind of AI we can do with a $40 single board computer. So my initial efforts with the Raspberry Pi 3 were very like underwhelming. Stuff would crash. You'd maybe get a couple of frames, and then something would hang. But the release of this kind of dedicated hardware really changed the possibilities for the Edge AI, particularly in the home, or you've got small throughput basically on low-cost computers. So yeah, if you're interested in Google's sort of take on Edge AI, definitely check out the Coral platform. This is hardware. They've also got a whole model zoo that is available. These are TensorFlow Lite models. So basically, these are TensorFlow models that have been trimmed down to operate on low resource devices like mobile phones or Raspberry Pi or these Coral devices, and they have some nice models that will do basic stuff. So they got like an object detection model, pose estimation. They can do segmentation. It's not just vision; they can also do audio stuff. So definitely check out that website. Let me go back to the project. So this is my first experiment in the home. So Raspberry Pi. This is actually a Raspberry Pi 3 with the Coral. And basically, the way it works is that had a Raspberry Pi camera. It would capture a frame. You then basically send the image over to this Coral device. It does the inferencing on that device, and then would return the results to a program running on the Raspberry Pi. And what this particular project was doing was putting a REST API in front of that backend, so that you could then use this Raspberry Pi in any other project that you've got. And what I actually did was ended up implementing the same endpoints that Deepstack currently implements. So basically, by adopting like a microservices approach, where you put everything in a little behind an API, the well-defined spec, you can end up creating more, a bunch of products or tools on top of that. So that's definitely something that has been a bit of a game changer in terms of making sort of Edge AI much more practical and something you can use in other tools like Home Assistant or other like security things people are doing around the home. So do people want me to talk more about the application, or are people interested in hearing about the code side of stuff, or do people want to hear about, I don't know, custom models?
Yeah, I'm curious to see how the code side of this works. Like, how do you communicate with the Coral device? Like, do you have like Python code running there?
Yeah, so...
and I'm curious about Jetson as well.
Yeah.
Yeah, we will get to Jetson. It's I figure this is like the kind of baby steps before we get to that stuff. So yeah, basically, Python. I mean, this is the sort of language that all, I guess, at least the data scientists that I speak to are using. People are training models with Python, so it seems only natural to use Python to enable people to use those models as well. And so this is the source code for that Coral Pi device. And basically, you import the hardware as an engine, and then what you will see later on, I'm just trying to remember how it works. They provide you with Google provide you with an API. So literally, this abstracts away all that hardware. You literally, I think that's right at the beginning. So this is a Flask app. This is running on the Raspberry Pi with that Coral device plugged in. So literally, I think it's really simple. There must be a main at the beginning. Right. So let's see. So, all right, okay. So the way I set it up was that you tell it which model you want to use. You can have a directory of models, like a folder of models, and it would load one of those in. And this is the line that creates the connection with the hardware. So this is, you get access to that TPU on that running on that Coral stick, and from a developer perspective, all you have to do is import this class here. So yeah, the way this works is we've got a little Flask app, and it's just exposing an endpoint on a particular port, and using curl or requests or whatever your preferred tool is, you post an image to the endpoint, and it basically will just pass out the bytes from that image, pass them to the Coral stick, returning an array of predictions, and then there's just a bit more code that formats those predictions into a JSON payload that's then just returned by the API. So the way I was using this actually was as a drop-in replacement for Deepstack, which at the time was closed source and didn't run on the Jetson. So that's originally was my motivation for sort of abstracting interactions with the Tensorflow light model in this way. So is that a useful introduction to how, from a practical point of view, you can deploy an Edge AI model then?
Yeah, I think so.
Yep.
The question that I have here is, the model that you're using is some model that they provide, or you train the model and then you're using it here?
So both. So this is my first project, right?
Okay.
Using Coral Pi. And at some point when the Raspberry Pi 4 came out, you don't need this Coral anymore, because the Raspberry Pi 4 actually is a pretty capable device on its own. So I archived this project, because what I found in practice was this whole need to connect it with a USB I don't know, sometimes it would just like lose connection. And the other thing I wanted to do was to wrap everything up in a Docker container so that you wouldn't even have to worry about your environment or anything. And I found that actually getting this kind of hardware interface to work with Docker was going to be a bit of a pain. So I ended up archiving this particular project and then moving to another implementation.
Just before we go very quickly, is the inference times that you have on Coral better than what you have on the Raspberry Pi 4? I imagine yes, right?
I think they're pretty comparable.
Okay.
Off the top of my head, I think I did some benchmarking. But, I mean, for my practical uses, there wasn't enough of a benefit from the inferencing time. Like, if it's 100 milliseconds or 200 milliseconds, it doesn't make any difference if you're only doing 1 frame a second anyway. It's like,
I see.
It's good enough. So for me, it was like, okay, I can shed some of the burden of having to maintain that support for that particular hardware and sacrifice a bit of performance. So that's what I chose to do in this case. So the next iteration of the project was basically exactly the same code, but without importing the hardware and not using that Coral Pi stick. The benefit here is it kind of simplified the sort of deployment, because like I say, what I really wanted to do was actually put everything in a Docker container, so that rather than having to, from a user's point of view, think, okay, I have to set up a virtual environment, make sure my hardware is in such a way. Instead, all you actually have to do in this case is just Docker run and, do your port mapping, and away you went. So that was the sort of next stage along. And, by implementing an endpoint with exactly the same endpoint, accepting the same arguments and returning the same formatted data, I could just swap out the first project with the second project. So this is great because I had everything set up for this to already work with Home Assistant. So that's how I got to the second iteration of this. Okay. And this is a bit of benchmarking I did, comparing both my MacBook Pro with a Raspberry Pi 4 and also looking at 2 different frameworks for actually serving up the model, Flask and Fast API. And you can see that Raspberry Pi, this is, I think, processing like a dozen images, was taking about 2 or 3 times longer than a MacBook Pro, which isn't bad, I think. So to come back to the model, okay, let me show you the model zoo, right? So there's a whole zoo of TensorFlow Lite models that Google maintain for you. I think it shows them here, but they have some really interesting stuff in there. They've got dog segmentation. You never know when that could be useful. Face detection, I'm pretty sure that. So okay, that's an image, but they do face detection. They've got various kind of iterations of some of the very common models. Inception V3, that's classification. And MobileNet, I think that's basic object detection. And they have some interesting ones, particularly like detecting particular kind of animals. So I think they had like a birds model and some other kind of animal related model. But to come back to your question about teaching them, did I train my own models in TensorFlow Lite? The answer is yes. And Google actually did quite a nice job of making that very easy to get going. So has anybody seen the Teachable machine before?
Yes. Nope.
No, I didn't as well.
Nope.
We've got 1 or 2 people there that have seen it, which is great. And it's basically like a web GUI where you can upload images from your local machine or from the Google Drive and create classification models in the browser. Well, obviously, actually, it might even be in the browser. I'm not sure, because TensorFlow Lite, there's a flavor of it that actually I think is in JavaScript and can run in your browser. But anyway, so basically, it's like a visual GUI where you upload your images. I think like a folder of cats, a folder of dogs. That's right, yeah. So they give you a box for class 1, a box for class 2. So you put 100 cats, 100 dogs. Select. Okay. No, it's not NVIDIA, but you can select the kind of model that you want to train. And then at the end, they have like an export button, and this allows you to export your trained model in a variety of formats. Optimized for the edge TPU, optimized, I think, like Android phone. They give you a couple of different options, but this is the tool that actually I used to create a very simple cats and dog classification model, just for the fun of it. And yeah, because what I discovered is actually classification models, they do have quite a lot of use cases, practical use cases. You know, so oftentimes somebody just wants to know, is there a car on the driveway or not? Is there somebody at the door or not? And actually, in those cases, you can probably get away with a classification model, which is pretty easy for somebody that not of experience to train. You just need a folder of each of the classes that you care about. Use a tool like that Teachable machine. It generates a little binary file that actually is the model, and then you could use something like this to expose that model in the standardized format behind an API like this. So that's where I got to with the Raspberry Pi. Any other questions about that before we move on?
Not on my side.
Yeah, I think I'm okay as well.
Okay, fantastic. So, okay, we're leaving Raspberry Pi and TensorFlow Lite land behind. And I mean, where I came to with this was, it works. You can run it on a Raspberry Pi, but the models are a little bit limited. So you can have pretty good classification models going on the accuracy benchmarks. But I was really interested in doing object detection. I wanted to count objects. And what I found was that the mobile net models and the other TensorFlow Lite models that were supported by the Coral hardware, they were lacking the accuracy that I wanted. So that's why I ended up leaving those behind. So kind of a useful stepping stone to where we're at now. And where we're at now is this project called Deepstack, which is by John. I won't even try to pronounce his name. Ola Fenwa. And I'm not sure if he's on the call now. He said he might be, but this is something that he's been working on. He was working on it in a private repo for a couple of years. And what this does allow you to do is to expose a variety of computer vision AI models via a very standardized API. So a RESTful API, actually implementing exactly the same endpoints as the one I used for my Coral project. And all of that using Docker to abstract away the actual software. So regardless if you're on a Mac or Windows or Linux or even a Raspberry Pi, you could just say Docker run Deepstack and then just tell it what endpoints you want to expose. So the most recent change in around Christmas this last year was that he open sourced Deepstack. Prior to this, it was closed source, and they had like a free tier and a charged tier, which was enabling like extra features like support for GPU, and there were some other limitations. But now everything's open source, and we're hoping to get lots more contributors to this library. Okay, so here we go. So it's had 3.2 million pulls on Docker Hub. So I think that attests to the popularity of Deepstack.
Yeah.
I'll let you in your own time check out their docs, but I think this gives you a little bit of an overview of the models exposed by Deepstack. What's that doing? Okay, so one's like the sort of developer website, and that's taking a little while to load. The other one is the sort of consumer manager's website, where it shows what could you actually do with Deepstack. Okay, so they describe it as an AI server for the edge, which exposes face detection model, face recognition, object detection, including custom objects, scene recognition, so classification. Oh, and custom object detection. And that's actually a picture that I generated with a custom model that is trained to detect if somebody's wearing a mask or not. So I'll jump back onto the Deepstack side. So what is Deepstack? So basically there's a Go server that sits at the front. Go was selected because it's ideal for this kind of application where you need a very fast response to requests. So basically, you have this Go server, which exposes various endpoints for face detection, object detection. When requests come in, those get put onto a Redis queue. So yeah, well, that's what it is, basically, a queue. And then in the background, you have Python, which is actually accepting the data off, putting the data off the Redis queue. So requests for processing images, and using PyTorch to run the image through any one of the models that's available to Deepstack, and then that data is then returned by the Go API. The way it's set up is, again, using Docker, and basically we're supporting a couple of different platforms, but including the Jetson Nano, which I showed you before. So, well, those are the build commands, but basically the way it works is regardless of which of those platforms, Windows, Linux, or a Jetson that you're on, you can use the same Docker run commands to bring up the API running on that device, which you can then integrate, with Home Assistant or any of the other tools that are out there that can work with the endpoints. So around Deepstack, there's a small ecosystem of sort of other tools that work with Deepstack. I'm responsible for a fair few of them, but they're starting to pick up other contributors as well. So within Home Assistant, we've got support for object detection, face detection, scene detection. I created a little UI for Deepstack using Streamlit. Has anybody else used Streamlit before?
Oh yes, yeah. I have used Streamlit.
Yep.
Yeah, cool. I mean, it's a really nice sort of way to build interactive dashboards. And so I created one in Streamlit for Deepstack, and it allows you to upload, images. They then get processed by whichever you can select between the object detection or face detection models, and it allows you to explore the results. And this is kind of where it gets a bit more interesting in terms of the practical application of object detection models. So to show you the scene outside my house right now, this is what Deepstack found out there. I was finding that this is at night. I discovered that there were several vehicles that always seemed to find classified correctly as cars, and several others, these two over here, that it was not ever picking up as a car. And I was like, why on earth is that? They definitely look like cars. So I put this image through the Deepstack UI, and it turns out that it's always classifying these two cars as suitcases. Very reliably classifying them as suitcases with a high confidence. So I ended up going back to my configuration for this and saying, okay, well, let's also include suitcases in the class of objects that we look for. And hey presto, is now reliably finding those two vehicles. So this is kind of like showing you some of the edge cases that you can experience when you put these models into practice. So that's where the UI came in, because I didn't really understand why it was not finding those vehicles until I put everything through a UI where you can go in and tweak the parameters that you're using to interpret the data that Deepstack is returning to you. So just to move on briefly to custom models, how are they supported in Deepstack? So Deepstack is, for its object detection, it's actually using YOLO v5. Which sounds a bit like YOLO 4 and YOLO 3 and all the other ones, but it was released, I think, like sometime last year, and there was a bit of controversy about it owing to the naming, and it seems like pretty much anybody can create a YOLO model and name it what they want these days. But this turned out to be quite a popular implementation. Where is it gone? What's the name of those people that do it? YOLO v5.
Are you looking for the Ultralytics implementation?
That's it, yeah, Ultralytics, yeah. It kind of gives you a good idea of why tools like Deepstack need to exist. Where's it gone?
Try on Google.
I think you had it there. When you typed YOLO 5, there was Ultralytics.
Really?
Yeah, I think it was there. There we go. Isn't that the second one?
Yeah.
Yeah. So yeah, YOLO 5. I mean, originally Deepstack was using YOLO 3. It was using YOLO 3 for a long time. YOLO 5 came along and it offered not just like I think like a small improvement in performance in terms of inferencing time, but no, actually there was a small improvement in accuracy, but a big improvement in inferencing time. So previously, like we had a benchmarking script, and I think with YOLO 3, if you wanted to process like 20 images on the hardware I was using, it would take like 10 seconds. And then in YOLO 5, it went down to like 1 second. It was some really order of magnitude improvement in the speed. And I think they've got like quite in detailed technical write-up on why that's the case. I think this is actually like a consultancy that created it, presumably around making a business on creating custom models using YOLO 5. But just to, so under the hood, Deepstack is using YOLO 5 models. And in fact, if you look at Ultralytics, they include the sort of standard thing of like a really long Python script with lots of quite specific requirements for how the data needs to be annotated, which is where ice fishing comes in, because it standardizes all of that and makes it a lot easier. But if we didn't have that, you have to approach something like this if you want to get started with training a custom model, and I guess even deploying it, like a very long script. So how we're doing it in Deepstack is we've just created. It's actually using that original script, but as a slightly modified version of it, so that all the user has to do is prepare their data using I think it's the YOLO format. So this is text. I think it's a text file or a JSON file per image, and then we have a Jupyter notebook which you can run on Google Colab. Which you basically just upload your annotated images and run the notebook, and it will at the end generate the model file, the .pt pytorch, a model file. And then if you want to deploy that with Deepstack, it's literally just an extra argument in the Docker run command to point to the location of the volume where you put that model. So that's how custom models are trained and deployed with Deepstack. So, that's the wrong notebook, actually. Okay, there's another notebook in there somewhere. So we've got custom objects. So this is the documentation for it. Describes how you can annotate the data using label. How do you pronounce that? Label image. And then links to the notebook where you can train your own custom model, your annotated data set. And then all you have to do is download that locally, put it on the machine where you're running Deepstack, restart Deepstack, mounting in the volume where that model is, and it will automatically generate an endpoint for that model. So from a user's perspective, we were trying to come up with the sort of, the simplest way of doing it. What's going on here? So that basically concludes the presentation for Deepstack. I guess at this point, I'll open it up for discussions and questions.
Yeah, I know some people had some questions on the forums before. I don't know if that person is here though.
I have a question around like the integration with the Jetson, right? The Jetson Nano. So in terms of, for example, the performance at inference time, I'm not, like you have a camera which has, records a stream of video at 30 frames per second, something like that. I'm not an expert, right? But then how does it work? Like, you're not, of course, you're not processing 30 images every second, right? You're probably sampling, and at what point, like, the Jetson is not going to respond anymore? Have you done any tests on that? What is the maximum you can push your device?
There were some pretty thorough articles on benchmarking of performance of standard models on Jetson. Turns out like benchmarking is quite a difficult thing to do in a really fair way. For example, if you're comparing like Coral TPU with some PyTorch running on Jetson, how would you even compare those two, because they're running completely different models? And there's always some extra, effects from like how you actually interface with those models, if you're going via an API or if you're using a dedicated script. So actually benchmarking is quite a sort of challenging topic in itself. So what I would encourage you to do there is just to look for one of those articles that was written on that topic. Coming back to your question about what is practical and when is a Jetson no longer practical. So 30 frames per second, there's not many things that move quickly enough that they're going to change much between one frame and the next.
Yeah.
The obvious example of a use case where that is important is like a self-driving vehicle. Well, obviously you're on the road, you're driving along 30 frames per second, you actually need to process every single one of those frames. For the applications that I'm doing, like detecting somebody at the door, like I could get away with like, even if I wanted to continually process that stream, even 1 frame per second is going to pick up somebody at the door before they've had a chance to push the doorbell. So you might say, okay, well, 1 frame a second, I'll use the Raspberry Pi then. But the advantage with the Jetson is you can actually load these much larger models, YOLO 5, for example, and get them more high accuracy, which, from my experience, is one of the most crucial factors, because there's nothing more infuriating than getting like a dozen notifications for something that's not there. So in practice, I tended towards the Jetson because of the higher accuracy of the models that are available. The other thing that the Jetson gives you is bandwidth. So you could potentially process like, there's obviously trade-offs here, but you could process multiple camera feeds, let's say, 10 frames per second, just using the Jetson. And they have this whole software stack just around taking frames off the camera stream and putting them through an optimized model.
Right.
So hopefully that answers.
Yeah, it does. And like as a follow-up question here. So have you tried deploying models on Jetson without Deepstack? So like running plain PyTorch or TensorFlow or whatever you've tried.
Yeah,
like literally having a script there which runs,
Yeah. So Jetson, obviously, NVIDIA, they published like a whole sort of stack of Jupyter notebooks, which allow you to do everything from like running basic inferencing to doing some like stuff with video feeds, to doing like very specific kind of models like key point detection. So if you just want to get stuck in, you're not interested in Deepstack, you just want to get stuck in and run models, they provide a really nice suite of material to get you started on that. I did the obligatory thing of like connecting a webcam up and waving at it and working through the notebooks and whatnot. But for my use cases, like the models that Deepstack was exposing, just a sort of standard vanilla object detection model with 80 classes in it, was okay for my practical applications. And I mostly put my effort into sort of crafting the integration with Home Assistant, because when I started this like a year and a half ago, I didn't know how should object detection work in the home. What do people care about? And when the first implementation, the first release, every object was you had a single confidence threshold for every object. But what you find is that, hey, the model has a much stronger bias towards detecting people, but I need a different confidence threshold to detect, say, a bus outside my house. So the next iteration of integration was allowing a confidence per class. And then, further refinements are about, okay, where in an image is something happening? And another refinement might be, okay, day or night, do I need different thresholds to detect what I care about? So that actually has kept me very busy to the point where I haven't actually experimented too much with different kinds of models on the Jetson. But just to come back to what I said at the beginning, there's a whole bunch of literature out there just to help you get started, and it's really approachable actually.
Yeah, just to add to that conversation, Jetson comes with Ubuntu 18.04. So you literally can do anything you can do in Ubuntu in Jetson, although it's on an ARM processor. And so it comes with OpenCV compiled for ARM processor. Actually, it comes with installed OpenCV 4.1. And so you can literally run a PyTorch model or install TensorFlow or install Docker. Or what they really want you to do is to use TensorRT. So it comes with TensorRT, which is NVIDIA's inference engine. So you can, and they provide you a good way to convert a PyTorch model into a TensorRT model, which actually goes through ONNX. So PyTorch to ONNX, ONNX to TensorRT. You could do the same thing for TensorFlow as well, which they claim is the fastest way to run more deep learning models on Jetson. But you can certainly run vanilla TensorFlow or PyTorch or ONNX directly on Jetson as well. When we looked at it, it was better than Raspberry Pi only because it just comes pre-installed. It's basically Ubuntu, right? So it's seamless inference from your development environment to the deployment system, and not a different OS completely. The only caveat is that like this whole Jetson is owned by NVIDIA, so it's not complete 100% open source, but it is still very useful platform to do a lot of things. Yeah, we were able to detect water bubbles at 8 FPS, and that was good enough for us. But I think they do claim that you can go up to 30 FPS if you use TensorRT. And if you really want to get extra speed, you can even write a C++ engine, then you can get the extra speed, but we didn't want to take the additional overhead. So we just stuck with Python, and then we're happy with the 8 FPS. So anyway.
Have you tried?
Awesome. Yeah. Jetson is definitely, and if your Jetson Nano is not a choice, you can also upgrade to Jetson Xavier. So Jetson Nano is like $99, but if you add chargers and SD card, it'll come to $150. And then Jetson Xavier is the next. Basically, the differences is really in the amount of memory that is there. So Jetson Xavier, I think, is 8 or 16 GB. I'm not 100% sure. There are two versions of it. I think it's goes for $400 or $299. I'm not sure now. But yeah, so those are additional things you might consider if you want to use it as a hobby versus professional. If it's hobby, then I think Nano is good enough. But if you wanted the additional memory, then you can certainly upgrade, to the next version in the Jetson platform, which is the Xavier version, which comes in 8 and 16 GB, which is plenty for most tasks from an inference point of view.
Did you try converting a PyTorch model to TensorRT?
Oh yeah. I did a lot. It's very straightforward, super simple. Primarily because PyTorch fully supports ONNX, so you can go PyTorch to ONNX TensorRT. Really straightforward. TensorFlow is much more challenging because TensorFlow doesn't want to work with the ONNX ecosystem in general. So it's more challenging to get TensorFlow to convert to TensorRT. But that also converts, but it's slightly more challenging, particularly when you use like certain TensorFlow operations that don't directly convert. But PyTorch is very straightforward. In fact, all of NVIDIA.
I see. You tried that with object detection model or classification?
We tried with RetinaNet object detection model.
Interesting. With the torch
we even converted RetinaNet from a TensorFlow as well. to TensorRT. That also converts.
And
it's just that you cannot do NMS. We were not able to do NMS in the conversion, so we have to do NMS in NumPy and not in the TensorRT graph. But otherwise, the core piece of it converts.
I see. And you like this RetinaNet model that you're talking about is the official one for Torch Vision, or you another one that you implemented?
Yeah. It's basically the open source vanilla one. It's nothing. There is no customization. Just straight the whatever is the basic basic pyramid structure. Yeah.
Ah, okay. Have you tried faster-rcnn or mask-rcnn as well, or no?
No, I've not tried any of that. Mostly because the RetinaNet itself gave us what we needed, so we have not done any other architecture exploration in that regard. But I think definitely when you do these things, start with the classification model, because that actually gets you the infrastructure piece of it out of the way, and then you can go into object detection piece, because classification is straight. It's very straightforward to convert those models.
I see.
And then you can iterate on it and build put some other model into it, like any other object detection model.
I see. Because we were trying to convert to OnXS, especially Francesco, and then we were having some problems with mask, right, Francesco?
Yeah, it was mask-rcnn. So I tried with faster-rcnn and RetinaNet, and it worked pretty okay. Actually, it worked perfectly.
But only with a byte size of 1, right?
Sorry?
Only with a byte size of 1?
Yeah, okay, yes, absolutely. That was another issue. That's another issue, yeah. The other issue is that dynamic axis doesn't really work, at least as far as I can tell, in Torch Vision. I'm not sure if you guys have any, a different experience, but yes. So that is kind of a limitation. So that I could just feed a batch of 1, but for mask-rcnn actually didn't work. So what I mean is that like I had like the original Torch Vision model, mask-rcnn, and then I converted that to Onyx, and that worked. And then when I tried inference on both the original pytorch model and the Onyx one, I got different masks, right? So pytorch model was returning different masks compared to Onyx, and I don't know why, and nobody knows why. But yeah, so that's kind of a different story. I dropped it for the moment because I got a little bit frustrated, but I'm gonna get back there one day.
Yeah, one day.
I actually had another question for Rob, if I may.
Yeah, go for it. Yeah.
So does Deepstack support classification as well, like plain and simple image classification?
We do. It's not custom classification models just yet, just custom object detection models. But there is a scene detection model in there.
Yeah. Okay. Because I was looking at that, and I was wondering if you had custom image classification, but that's not the case for the time being. Is that correct?
Well, not unless you want to make a pull request. I mean, it's open source.
That's a very good answer. I love it. Yeah.
I mean, like I say, like classification models, you kind of think, oh, that's cats and dogs. I don't need that. But actually, there's lots of practical applications where that's good enough. And it's like Sam said, you first you kind of prove the principle with that, and you might find that actually that solves the problem that you're working on pretty well.
Yeah, because I was thinking about damage detection, right? And in some cases, I don't really need like to. I mean, of course, like object detection is probably like more suited for damage detection, because you might want to know where the damage is, like in the picture. But in some cases, you just want to know if within the picture there is damage, right? And just, for example, like stop like a line, like a production line, right? You want to stop a production line because you know that there is something wrong in that frame, right? And so that's a lot easier, right? You just have like a bunch of pictures with damage, a bunch of pictures without damage, and then you just run a binary classification, right? And so that's why
I'm guessing that in practice they have like maybe an ensemble of models, like all looking for different kind of features, and then you just give the confidence for each one of those, like 74% scratch, 32% dent, something like that.
Yeah.
Yeah, those models are particularly easier to train as well. So.
Yeah. No, yeah, I was looking into Deepstack specifically, just for the specific question, because I love the Docker abstraction, right? So that it's supported by default, and so I wanted to know if that was supported. But yeah, I guess that a PR is always welcomed. So we can work on that.
Rob, I have questions about the Docker image, the Deepstack Docker image. I guess it's built on top of the Jetson Docker image, and then they add the models, or
I think yeah. I mean, it's like a base image for Deepstack, and then a couple of other images, hardware specific for the Jetson hardware. And I think the models as well. So earlier on, Sam was talking about the TensorRT optimization. We haven't done that yet for the Jetson models, but just from reading about it, we think we're going to get a factor of 2 improvement in the inferencing time just by doing using that TensorRT. And you can even get a bit more specific, so you can optimize for particular flavors of the Jetson hardware. So you've got the Jetson Nano, which if you use it as a benchmark, then there's the Jetson Xavier, which is a more capable machine. Just from reading a few articles about it, it seemed like a model you can get double the performance on the Xavier, but only once you've done the TensorRT optimization. Because I actually own both of those 2 bits of hardware right now. They both run at exactly the same time. But it shows you there's still margin, definitely margin to be gained by optimizing for that particular piece of hardware. So that's on the roadmap for Deepstack, and we want to get to the point where you can say I want to run the mask detection model, and it will automatically select the model which has been optimized for your hardware to give you the best possible performance. So that's where we want to get with that.
Okay.
And I have a question.
Sorry.
Go ahead, please.
So about the, do you throttle the image that you feed your model, or what do you do? It's the application that takes care, like in order not to get the 3 FPS.
So do we throttle the frames that are being processed by Deepstack? Is that the question?
Yes, because I guess you're not going to bombard the your Jetson with the 30 FPS. Do you select like one image every, I don't know, for example?
So there's two ways you can go with this, right? So Deepstack uses Redis, which is basically just a queue. So if you hit it with more and more requests, it would just add those to the queue.
Okay.
But the other approach, which is what I did in my with my Raspberry Pi and the Coral stuff, you don't have a queue. You just sit there and you just hope that, okay, I'm not going to hit it more than it can handle. And so with Home Assistant's integration, right? Home Assistant, it's not a video processing piece of software. It's a home automation platform that has like some video capability, but at most it does 1 frame per second on Home Assistant. You can't. Okay. It's not for video, right? So you're never, in fact, it's going to hit Deepstack particularly hard using Home Assistant. Some other people have done projects where they've written code that will do 5 or 6 frames per second. People that want to track moving things, they would typically need to do that. Deepstack should be able to scale to the point that the hardware can handle it, and there's definitely a lot of room for optimizations and improvements under the hood there as well. So we had a couple of guys from NVIDIA reach out to say, hey, Deepstack looks really cool. We want to learn more about it. So we're hoping that over time it will gather momentum, and the fact that it makes it very user friendly to get started with the hardware and the models will draw more people to the project. But if you just want to do something really simple, create an endpoint, and you're not going to hit it particularly hard, you can just use Flask or Fast API, half a dozen lines of code to abstract that away and put it behind an endpoint that you can then use in practical applications. It doesn't need to be too complicated.
Cool. Thank you.
Yeah.
Thanks. Yeah, I had a follow-up question there actually. So the Deepstack is running as a Docker container, and it can take in images, right? And then you have a separate application that is capturing the feed from the camera, and then is it writing to a file, and then you put the file name into the Redis queue, or how does this process go when you communicate between these two independent processes that is running?
So, I mean, you literally just take the image, convert that to a byte stream, a stream of bytes, and post that as a string, basically. So there's, I mean, Home Assistant isn't saving a bunch of files in the background. It's actually just directly pulling the pixels out as bytes and posting those to Deepstack. One of the things the integration that I created does is it then, once you've detected something in your image, it will save that as a JPEG locally and put the bounding boxes on it, which is actually what is displayed on the front end that I showed you. So there's no need to actually save any files at all. You can do everything in memory.
Okay, gotcha. So that saving of the file with the bounding box is done by the Home Assistant plugin, or is it in the Deepstack itself? Deepstack just returns you the coordinates of the bounding boxes, right?
That's correct. Yeah. So the Home Assistant it takes all that data and it says, okay, let's combine that with the image data, and I think we're just using Pillow to draw some boxes on it. It's not particularly sophisticated or anything, but it works, and
okay.
so that's how you see that display. I mean, going forward, we want to think about how do we improve the way Home Assistant works with AI and sort of object detection models and computer vision models, because like Home Assistant is used to automate people's homes, and it has a concept of like a homeowner and people, that kind of thing. But it'd be really nice in the future to tie it all together so that Home Assistant would say, "Hey, I've spotted Robin on the camera coming up the driveway," or turn on the lights, something like that. So there's lots of scope for improvement. It's still really early days in terms of the actual integration into real daily life, I think.
Interesting. So just on the other side of the Redis queue, is it your Flask application that reads the queue and then calls the Deepstack API, or is Deepstack reading the Redis queue?
So there's a little Go server, and I don't know any Go, but I think basically the way it works is it spins up a few processes, and these Python processes just sit there checking the reader's queue. I think it happens like every 0.1 of a second or something like that. So there's we had a suggestion about how to improve that, so you can turn that from a polling into more of a kind of triggered approach. But yeah, basically this Go server is orchestrating everything in the background.
Okay.
Is it the Home Assistant that subscribe to the or push to the Redis, or?
So Home Assistant is we're just using the request library in Python to post the image data to Deepstack via its RESTful endpoints.
Okay.
Yeah, it's really simple stuff. Like Deepstack provides the abstraction. All you need is Docker run. Hey, I've got a REST API available, and the Home Assistant is just patching into that via using the request library. I mean, you can use curl. Or, there's other sort of approaches out there as well. I think there's like RPC queues. I don't know if anybody knows about that, but it's a level that's even more low level than HTTP requests. That is, I think, faster, and some of the other tools out there use that approach.
Okay, so it's just Home Assistant that is posting the request there, and then from there, Deepstack will take care of the put it in Redis, and then there's like another process that takes care of reading the Redis and then process the image by image and then return it to.
Yeah.
Okay.
There's a really nice article. I don't know. Do you know that blog PyImage Search?
Blog Py? No.
Yep.
Yeah, the blog
Adrian
post. Yeah.
Something or other.
Adrian Rosenbrock.
Yeah, he had, I guess, article with the guy that wrote Keras, that Francois guy, and they showed you how to make a simple REST API for exposing, I think, a TensorFlow classification model. That's a kind of nice intro. That's originally, that is like the original article on how to create a REST API for a machine learning model. There was a follow-up article to that where they actually say, well, how do you scale this to a more of a production system? And there they actually show you how you can use Redis and some other tools to add that scaling capability to it. So that's a really good introduction to the topic of how do you make something more production ready. So definitely check it out.
So like there is a parallel if you want to have like an enterprise grade solution, because I see that they use Kubeflow from Kubernetes, and I guess Kubernetes, I think they use Kafka, or
sorry, what are we talking about? No, we're not talking about Deepstack. We're talking about something else now.
I'm trying just to see the parallel between, for example, the solution that you have with Deepstack using Redis, and the solution that are used like in industry grade, solution using Kubernetes and in the cloud, and because you have they push a lot with the Kubeflow from Google, so Kubernetes and I don't remember. I have the impression that there they use Kafka, but it's the same principle.
It's always the same principle. Put your requests on the queue. Something else picks them up. If you need more capacity, you just spin up more. Blah blah blah. Whatever's.
Yes.
Yeah, I mean, I've also done a bit of work with AWS services. So they've got a service called Recognition, which does scene and object detection. And it kind of works in a similar way from the outside as Deepstack. You just got, REST API, you just post it the bytes and, whatnot comes back. I actually found when I compared Deepstack with Recognition like a year ago, and my kind of very sort of basic experimentation, I had the impression that Deepstack was more accurate and faster, right? Because you don't have to post it over the internet. Deepstack is connected to my router. There's no latency there whatsoever. Over time, actually, Recognition seems to have got better and better. Presumably, they're improving their hardware. I know that AWS have their own like Tensor hardware now, and the model definitely has improved in accuracy quite a lot as well. So it'd be quite nice, obviously, to have a local and open source alternative to Recognition, and I think that's what we're hoping to achieve with Deepstack.
Have you tried TorchServe as well?
TorchServe, yeah. I mean, from a user's perspective, like you look at a tool like TorchServe, and I think there's like one for TensorFlow as well, and you immediately come up against like a wall of, okay, here's the YAML you're going to need. Like they always make it easy to do like the basic hello well, but then when you say, okay, I want to put like custom object detection model, it's like, right, here's like a 300-page README, and you're going to need to know YAML and Kubernetes. Deepstack just made it all into a Docker run command, which I think is why it is really popular.
I see. Yeah, I think the way that TorchServe is moving, the last time I tried playing around with it, it's actually pretty cool. You just need to provide like the weights for a model, especially for the Torch vision models, they have support for that. And then you just like run TorchServe command, and then it also just exposes an API, a REST API, I think, for you to interact with.
Yeah, I think this is the way it's going, isn't it? I mean, Deepstack was not the first AI in a Docker container service. There was one I was using before that called Facebox, which is the same thing. That was a startup, two or three guys based in the UK, and they ended up selling that to some company that does like sports streaming, and they all got rich basically. It seems to be a good idea.
So Deepstack, they have their own model zoo, from what I understand. And
that's the way we want to go, right? So if you go onto their docs site right now, So this is like the really cool thing about it being involved in open source. I think, we put it out there, nothing happens for like a month, everyone ignores it, and then some random guy is like, "Yeah, I created a model to detect license plates in Norway." I think it was Norway, and we're like, "Oh, that's cool." And then somebody else come along. "Oh, I've done one for, I don't know, mask detection." We're seeing even today on Twitter, I saw some guy who's usually like making YouTube videos about home automation. He's like, "Yeah, I just trained a custom model and deployed it with Deepstack." I'm like, "Really? That's awesome."
Cool.
With like people that
cool.
don't consider themselves like deep learning practitioners can create a model and get it, put it in use in their home. I think that really is, kind of a watershed moment.
Yeah, totally agree.
It is really cool. It is really, really cool.
And what is the business model of the Deepstack? How do they? Because now they are giving it for free. No, at certain point they had like a private.
Yeah, originally
solution.
it was like in a private repo. That's how to get into the Docker container, and they had like a kind of an enterprise offering. So like there's a free tier where you could get like the models, and I think you could train like 5 faces because you can do facial recognition, and custom models were going to be like enterprise only. But actually, both those guys got really plush jobs at Microsoft, and they're like, "Hey, we don't need the money," so they just open source everything. And right now, the business model is, well, this guy John is he's a sort of core maintainer for it. We want to obviously bring more people online and contributors to that. And in terms of like the business model around it, how do you make that sustainable? I think the model here is kind of like a consultancy. Right? So an enterprise comes along and says, "Hey, I need a very specific kind of object detection model for damaged vehicles, or whatever." And I see that you've got a way to deploy it. Can somebody create this model for me? Or that's one way I see it sort of being turned into a business, if you like. I think their vision really is to make a tool that is used by like the average developer to create other products as well. So yeah, in terms of like how you monetize Deepstack, I think sort of consultancy side, but to be confirmed.
That makes sense. I mean, they are developing like an expertise in how to deploy the different models and how to train them and how to deploy them.
Exactly. And I think there's big benefits. I think like Home Assistant is quite a good example actually. Like the best quality software is software that's like developed out in the open. And to give Home Assistant as an example, it was started by one guy who was just writing Python scripts 7 years ago, and now it employs I think like 6 people full time. So it can evolve, and it picks up a lot of momentum. It can be a livelihood for people as well.
Yes, Home Assistant, they have their own product, from what I noticed on their Twitter.
Yeah, they just released. You can order for like $150, I think. Single board computer. It's pretty good specs actually, and everything's on there. It's like almost like Apple TV kind of grade experience. Like plug it into your router, use the app, set it up, and off you go. I'm not sure I don't think they actually make any money off that. They have a cloud component. So actually, coming back to your other question, how do you monetize this? Always the answer is a free tier and then something for the corporates.
Yes.
But to give Home Assistant an example, they've got for $5 a month you can get an integration with their like cloud platform, which then actually enables you to access your Home Assistant from anywhere in the world, right, securely. You can do it manually, right? You have to set up like all these certificates and SSL stuff.
Yeah.
I tried this, and I think I'm reasonably technically competent, but I got fed up with it, and I was like, "Solve that." And then they produced this thing. I was like, $5 a month, yeah, that's worth it to know that something's secure and somebody else taking care of it for you. So that might be another way that Deepstack will go. We've got this implementation you could put on your hardware, and anybody can use that. But if you want a fleet of like 500 devices, okay, now you go to the corporate plan. Or if you want something that can like scale and push stuff onto AWS or whatever, there might be a sort of an enterprise angle on that.
And I guess there's a lot of competition there between different the manufacturers or
there's definitely
providers
an arms race going on. Like you can feel it. You've got Intel, they've got their hardware. You've got Google, they've got their hardware.
Yes, yes.
Obviously, NVIDIA. I'm sure there's other companies out there, and they just know that in the same way that like smartphones are everywhere. I'm guessing GPUs or whatever will be everywhere in 10 years' time, and they all want to be the bedrock for that. So you can feel it. I mean, for me personally, what would be a really good outcome of all of this is like NVIDIA come to us and say, hey, this is awesome. We want to pay you guys to go full time on this, change the world of it. I mean, that will be like a dream outcome from being involved in all of this. So we shall see. You never know.
That's a very good option there. Yeah.
All right. Have we got any other questions, or I'll hand it back over to one of you guys to, I think there's something else we wanted to talk about.
Yeah, we have a question here that let me check. So it is. I had it 1 second here. Jay Artist asked today afternoon. He wants to know if the deployment between Jetson Nano and Javier changes or is the same thing.
So it's exactly the same thing, right? It's actually the same even if you're on Windows or Linux. It's the same commands that you use with Docker. It's the developers that have done the legwork in the background to make it that kind of seamless experience. I think we ideally want to keep it that way, but as I mentioned earlier on, there's potential hardware-specific optimizations we can do, and it might be the case that at some point you would need to download a different model if you've got a Xavier or a Nano. But right now, if you're just using the vanilla model, it's exactly the same.
I see. Thanks.
Cool.
Yeah.
Cool.
By the way, I tried installing Torch Vision on Jetson today, and it was a bloodshed. Sorry, I had to rant uselessly, and then I would go on mute.
So you see,
I failed, by the way, so it's not installed yet. After 7 hours.
You could have installed Deepstack by now.
I know exactly. I know. I don't even know why I'm talking about Torch Vision at all. That should be Deepstack.
So you see, Rob, there is a market there.
Yeah, there's a market of people suffering, trying to install Torch Vision. There you go.
You just listen for the swearing and you walk towards them.
Oh God, yes. You should have been here. You should have been here. Yeah,
I've been there as well.
Yeah, there you go.
On Jetson, you use CUDA as well?
Are you asking to me? Because I don't know. I hate it.
I don't know. Anyone knows the answer?
But I guess if it comes from NVIDIA, you expect that it's CUDA compatible, no?
I don't know.
Yeah, you do use CUDA. I think it's 10.1. I think latest.
Okay.
But it is shared memory, so it's not CUDA memory is not independent from main memory. It's a shared memory.
Oh, interesting.
There's actually a benefit to that, is because there is no memory transfer happening from your RAM to GPU RAM. It's basically the same memory block, which actually is why it's somewhat faster. I don't know what the trade-off is, but the shared memory is how they have built it.
So when you are using like PyTorch, the calls they can normally do tensor.cpu or tensor.CUDA. That doesn't do anything then on Jetson. Both are the same.
I want to say I've not used PyTorch. I did use PyTorch directly. Because if you go to NVIDIA examples for Jetson, they have a Hello World examples, and they do use vanilla PyTorch and actually Torch Vision as well to capture the camera feed. And I don't think you use any two CUDA in there. I'm not sure now. They have a notebook. I can try to find it and post it on the chat here.
Cool.
Yeah, because I just use TensorRT. Really know how the whether to do CUDA or not in PyTorch when you use Jetson. But I want to say you don't, because there is no difference between, there's no CPU and GPU difference in Jetson. But yeah, I can try to find out an example of that notebook that NVIDIA released and see if that helps.
All right, thank you.
So your motivation of using TensorRT is performance?
Oh yeah, definitely. It's at least 3 times faster.
3 times faster.
Yeah, 3 times faster than this,
Okay.
and it also consumes less memory compared to both. TensorFlow is the worst of all because it consumes all the memory, a lot of memory, but in PyTorch also consumes a lot of memory compared to TensorRT. TensorRT is not only fast, but also it consumed less memory, is why it's easier.
Is it because they optimize the Onyx Onyx file?
Because
the Onyx model?
Yeah,
okay.
Not the Onyx model, but when you convert Onyx to TensorRT, you have some flags you can set. So for example, we use FP16 and then
okay.
Yeah, so there are some flags. I know. I don't want to say that you can't get to the same performance if you use PyTorch directly or TensorFlow directly. Probably you could. It's just that it was only a couple of commands to convert it, and I was getting performance boost. So that's why we never looked back and said, can we do the same thing with vanilla basic, directly with PyTorch or TensorFlow, because that motivation was not there.
So I guess they do it like transparently, in the sense they go and do all the optimization that you would do manually. They automate
somewhat. Yeah. Yeah, somewhat. Yeah. That is a piece of software. I don't know if Tensor, but that's a piece of software you don't fully, because it's mostly written in C. So it's really hard to go down and see what they really do there.
Yeah, because it's closed there.
Yeah, that is. Yeah. And also you have to specify a batch size. So every forward propagation in the inference, we always used to give a specific batch size, whether it is batch of 1 or batch of 8 or batch of 4. You have to, when you build the TensorRT engine or TensorRT, the weights file, you have to specify what is the batch size, because it allocates memory based on that. Because it converts your basically your tensor 2D tensor or 3D tensor of inputs into actually a 1D memory block, and so it needs to pre-allocate the memory block, and then it just copies any new data to that memory block. And those are the kind of optimizations they have done to make it faster instead of reallocating memory over and over again.
Yeah, very nice. Does anyone has any other questions? I think we're done here. All right, so thanks a lot, Rob, for yet another presentation. It was very, very cool. I'm very interested in this deployment in edge devices. Yeah.
Thank you so much, man. I really, really appreciate your time. So thanks a lot for sharing what you learned on the way. It's really